Hello, today I want to talk about physical instabilities in physics engines. And I think we've all been there. We have played some video games that display some sort of physical instabilities. Maybe you shoot at a guy and he just flies off into oblivion. Maybe you drop a grenade and see that the characters become like spaghettis and then they just fly into the sky. Or maybe sometimes you throw a character off a cliff and suddenly he bounces off and flies into the stratosphere. So that's the kind of thing that usually happens, and that's the kind of physical instabilities that I'm talking about. So let me show you. Let's start with a simple project, an empty project, and let's add a simple, very simple prop. This will just be a basket full of fruits. What could possibly go wrong? Probably nothing. So here's my basket. It has some tangerines, some apples. If we run it, we can just walk all the way and inspect it, and everything looks fine. Nothing wrong can come up out of this, right? Just a basket, just some fruits in it. And here's the cool thing. We can set up a simple environment and just use our baskets full of fruits and use them as shooting practice. Let's shoot at this one. Oh, there goes the fruits. There we go. Cool. Right. Very cool effect. If we explore the collisions in the basket, we have two types of collision. We have a complex collision and a simple collision. Simple collision is usually the one we use for the physics interaction, and complex collision is more for other tasks like ray tracing or something like that. But we have to be careful about something. Let's suppose we are just given the basket's 3D mesh and we want to create a collision, and we go here and just add the simplest form of collision, like a box. But wait, we already had a simple collision and now I have two of them. Now I have my simple collision and I have a box surrounding my basket. So this means that the fruits will be trapped inside, doesn't it? So let's see this in action. I'm gonna clone a basket, put it on the floor. I already set up this demo, so I have just one checkbox to click and the basket is gonna be sealed. So the fruits cannot escape. And I'm gonna clone the basket. And this basket is gonna be the normal one. I mean, not sealed. Now if I run the demo, and I look at the fruits on the left. They're all moving around the place because they cannot escape. What is really happening here is if the fruits slightly overlap, there's gonna be a force applied that is gonna separate them. And that's why we get this bubbling effect. So if we can see this in Chaos Visual Debugger. This is our physics visual debugger when we can inspect the physical world and actually see what is going on. I'm just gonna move over to the baskets. So when the world is spawned, notice that all the blue objects are static and the yellow objects are physics objects. And if they are yellow, that means that they are alive right now. That physics simulation is being applied to them. Well, they were just spawned in the world, so it's normal for them to be awake. But then they turn red. That means that they stabilize and they start to sleep. They go into sleep mode. But notice that our sealed basket is definitely not sleeping. It is quite awake, and if we zoom in and we hit play, you see why. The fruits are being pushed around, creating this bubbling effect. This object is not stable. So if you go back to our simulation and we run it, now you're wondering, what happens if we shoot at the two baskets? Well, let's see. As expected, oh, it's not moving. And now, let me add a widget that is going to explain more or less what is going on. And there we go. You see the nuclear instability is just a measurement of all the energy that is present in the basket. This is just the sum of all the energy inside the basket. And since the basket is totally sealed, the energy that is active at this very moment, where is it gonna go? I mean, the basket is sealed. Yes, I know that this is a simulation, it's not an accurate representation of reality, but for a practical sense, we can say that the energy is trapped. When we are shooting at the basket, we are making the fruits move, so we will have more fruits overlapping, we will have more penetration among the fruits, thus more energy to spread them apart. I just stopped it at the right moment. This is the amount of energy. And this is the amount of accumulated energy. But look at here. This is the interesting part. A fruit managed to escape the basket. And remember, the basket is sealed, and yet the fruit was pushed out with so much force, the engine couldn't keep up, and the collision was not evaluated in time, and the fruit could escape. So if a fruit can escape the enclosing, the collider, in a physical sense, it will just mean one thing. The enclosing was breached. So what will follow is that all the energy that has been churned inside the basket will try to get out at the same time. So this is the total energy that the basket has, but it's not gonna spread in a linear fashion, it's gonna spread in all directions. So since we're in 3 dimensions, we need to take the cubic root to more or less calculate the impulse and the radius. We can use the terms interchangeably. And this will kind of determine the radius and the force of the blast when all the energy escapes at the same time. But as the energy moves outwards of the center, of the epicenter of the explosion, it's gonna kind of dissipate and it's gonna weaken. So we can try to normalize the distance over the radius of the blast that we originally calculated, and we can also calculate a falloff factor. So, okay, this is maybe a lousy formula, but it's good enough to see, how ridicule the thing can become. Let's see what happens if I start shooting and I simulate all the energy coming on out of once. So I'm disturbing the basket. I'm shooting at it constantly. I'm gonna shoot it so much that I want to make a fruit escape that simulate the hole being breached and all the energy released at once. And let's see what happens. I'm gonna keep shooting at it. I keep shooting. Okay, this is gonna take a while. We need to get enough physical instability to make just a fruit fly out. Oh, there we go. And I'm dead. The blast actually killed me. Took me a while, but the blast killed me. Okay, kind of cool. Let's try to add the widget to the other baskets to see how stable they are, or they aren't. So now we have markers for the other baskets. I'm gonna choose the grenade launcher this time. I'm gonna shoot. Oh, I'm dead. I think 2 of them detonated actually. I think one detonated and it detonated another one. Let's try again. I'm just gonna shoot normally. Okay, it hasn't exploded yet, but almost exploded. Oh, there it is. And I'm dead again. I'm gonna choose the grenade launcher. Oh, now I'm keeping a safe distance. For a physical instability, it's kind of stable. Oh, I take back what I said. It exploded with such force that it threw me out of the world. Well, here's the thing with physical instabilities. They can be very unpredictable. Let's have more fun. I'm gonna select this basket. And I'm gonna lift it up very high so it drops. The drop should be enough to get it to make it so unstable that a fruit is released and all the energy is released as a consequence. Let me make actually another copy of it, maybe from a higher distance. And yet another copy. A little higher perhaps. I'm gonna go into a safe distance. I want to remove the widget so we can get a better view of the chaos. And from a safe distance, I'm not gonna run this time. I'm just gonna simulate and see what happens. Whoa. That was a lot of chaos. Just for clarity, this is definitely not the way that you would implement a bomb. Not by adding a basket full of fruit and making become unstable. I mean, there are simpler forms, but this is just a demo about how a simple prop like a basket full of fruits that you can shoot up can become so physically unstable that it can become a bomb. Oh, look, the NPC just flew away. So what's happening in the real world? If you make these kind of props, will they explode? No, they are exploding because I decided to program them to explode. What would actually happen? You will not get an explosion, but your frames per second will be highly impacted. I mean, the quality of your game is gonna deteriorate because we are going to be spending precious CPU cycles and GPU processing power to actually try to stabilize these unstable systems that enforce. Physics engines are very, very, very fragile and they are very prone to physical instabilities. So I just made this video to show you. Misconfigured props can cause physical explosions, not in the quite literal sense of the word, but they can make your CPU spike. My recommendation, keep a close eye on your physics props. And the next time that you see weird stuff in a game, just remember someone somewhere misconfigured a physical element. And as you have seen, it is very, very, very easy to misconfigure and to make an error. So don't be so harsh on the programmers. Okay? So thanks for watching and I hope you enjoyed the video and see you next time. Bye.